Welcome to lecture 11 of CSE 4635. This lecture is going to be the last lecture before the mid exams, and the topics that we will be covering in this lecture are scoped parameters, JavaBeans, common design patterns like Model 1 and Model 2 architectures. Okay, so let's begin. So today we will be starting our discussion based on the different kinds of scopes that exist for different kinds of parameters and attributes. So depending on the kind of scope, we have different kinds of parameters and attributes like servlet config parameters, servlet context parameters and attributes, session attributes, request attributes, and page scoped attributes. Now, among all of this, page scoped attributes only apply to the attributes that are defined in JSP pages. So now let's take a detailed look at each of them. So first comes the servlet config parameters. Now we know that servlet config is an interface in the servlet API, which is used to initialize our servlet in the web application whenever our web application is run for the first time. So a servlet config object is created for each servlet that is present in our web application. Now, if we want to specify any number of parameters or any number of initial parameters for any of our servlet, then we need to do that through our deployment descriptor or through our web.xml file by using this initParam element. So if you can see this in this example web.xml file, we are registering a servlet called servlet config test. And inside this registration, that is inside this servlet tag, we are defining another element or another tag called initParam. And this initParam element consists of a param name and param value pair of elements. So for the param name, we will be writing down the name of the parameter that we want to define. And for param value, we are going to write down the value of that parameter. So in this way, it is possible to define multiple parameters for our servlet here. And just for example purposes, we are using a parameter called topic name. And as for the value of this parameter, we have given servlet config params. Now, if you want to access this parameter value and access this parameter, what you have to do is inside your servlet config test servlet, you will have to write something like this. So at first, you have to get your servlet config interface by calling the get servlet config method. And on that interface object, you have to call the get init parameter method. And inside the get init parameter method, you simply need to pass the name of the parameter whose value you are trying to get. So in this case, since I have written string name is equal to get servlet config dot get init parameter topic name, this name variable of mine is going to store the value servlet config params. Okay. So when it comes to servlet config, what you need to remember is for each servlet that is present inside your web application, one servlet config object is always going to be created. And the way you can access the initial parameters that have been defined for servlet config for that specific servlet is by using this servlet config object. All right, so we can say that the scope of these parameters is restricted or is limited to that servlet. Essentially, what that means is you cannot access this parameter, that is this topic name parameter, from some other servlet. This parameter is only going to be available under the servlet config test servlet. All right. Next, we have servlet context parameters. Servlet context object represents an entire web application inside a single JVM. When you deploy your web application on a server, for example, on a Tomcat server, a servlet context object is created for that web application. Now, this object is common for all the servlets and all the resources that you have inside your web application. And as a developer, you can use this object to define different initialization parameters for your whole application. And the way you define these initialization parameters is through your deployment descriptor, that is through your web.xml file. Now, if we take a look at the sample web.xml file again, as you can see, we are using an element called context param, under which we have defined param name and param value, key value pair essentially. So what is interesting to note here is we are defining this context parameter under the web app element. But in case of servlet config parameters, we would have defined this initialization parameters under a specific servlet. Okay, so from this, we understand that context parameters are accessible to all the servlets inside your web application, but config parameters are only accessible to the servlets under which those parameters have been defined. So anyway, in this case, we have defined the name of the parameter as a global variable and the value of the parameter as javacodegeek.com. So this is the website from which I have taken this example. And the reason this variable has been named as global variable is because of its similarity to global variables. So you can compare servlet config variables as local variables, which are only accessible to the local servlets, and you can compare this servlet context parameters as global variables, which are accessible to all the servlets and all the other resources inside your web application. Now, if you want to access the value of this context parameter, then all you have to do is inside any of your servlet, at first you have to get your servlet context object by calling the get servlet context method. And on that object, you will have to call the get init parameter method. And inside the get init parameter method, you will simply have to pass the key name of your parameter. So in this case, this value string variable is going to store the value javacodegeek.com. So from this, we understand that the context parameters defined through web.xml are accessible through the servlet context object and are available to the whole application. So we can say that the context or the scope of this servlet context parameters is application-wide. Now, in case of servlet context object, it is possible to get to set both parameters as well as attributes. The difference between servlet config and servlet context is the presence of attributes in case of servlet context. You cannot have both parameters and attributes when it comes to servlet config, but you can have both parameters as well as attributes when it comes to servlet context. Now, if you're wondering what the difference is between servlet context, if you're wondering what the difference is between servlet parameters and attributes, then the difference is actually pretty simple. You see, parameters are read-only, but attributes are both read and write objects. That is, what that means is once you define parameters through your web.xml file like this, you cannot change their value, they're fixed. On the other hand, when it comes to attributes, you can simply use the setAttribute method to change the value of your attributes. Another difference is that parameters are only string objects. That is, whenever you define any parameters through your web.xml file like this, they're always going to be string type objects. On the other hand, when you set any attributes to your servlets or to your servlet context interface, then what happens is you can set any type of attribute. You're not only limited to string type objects. All right. And the way you can set attributes to your servlet context object is simply by calling the set attribute method on your servlet context object. All right. Now let's talk about session attributes. So as the name already suggests, these attributes have the session scope, so their lifespan is valid as long as a particular session is valid. So we know that it is possible for one servlet to have multiple sessions, right? And these sessions are managed by the web container and the client by a session ID mechanism. Again, remember, session attributes are valid as long as that particular session is valid. So if you want to set any attributes to your session, it's pretty simple. Inside your servlet or inside your Java code, what you have to do is, suppose in this case, I want to store this shopping cart object inside my session. So what I can do for that is I can simply call the setAttribute method on my session object, and inside the setAttribute method, I will be passing two inputs. The first input is going to be the key of the object that I am passing, and the second input is going to be the actual object. So this is essentially a key value pair that I am passing onto the setAttribute method. Again, if I want to get this attribute from this session again, what I have to do is I simply have to call the session.getAttribute method on my session object and pass the name of the key whose value I am trying to access. So in this case, I will be returned the shopping cart object that I had saved in this line here. So again, remember, since these attributes are session scoped, they will be destroyed as soon as your session is invalidated, right? Now let's talk about request attributes. So we already know that it is possible to have request parameters, right? So these request parameters are available through HTML forms that we fill up. So whenever the input data inside an HTML form is passed on to some servlet, then we can get those parameters by using the request.getParameter method, right? So other than these request parameters, it is also possible for us to set request attributes as well. The lifespan of these attributes is as long as the request is being processed. So once your web application sends back the client a response related to the client's request, then the attributes that you have set for that request will be destroyed as well. Now, if you're wondering why we need both attributes as well as parameters, well, when it comes to requests, well, the reason behind this is remember the differences between attributes and parameters. You cannot really change the value of parameters, but if you want, you can change the value of attributes. So let's think of a scenario like this. Suppose I want to store this shopping cart object on my request object. And the way I can do that is by using this setAttribute method on my request object. Inside this setAttribute method, I will be passing a key value pair, just like the last time that we saw. So the first input is going to be the key, and the second input is going to be the actual object. And suppose I have one servlet called first servlet, and I am calling another servlet called second servlet from this first servlet. Now, this first servlet performs some kind of processing on this shopping cart, and my second servlet is going to be responsible for performing some other processing on the same shopping cart object. So how do I pass this same shopping cart object from one servlet to another? Well, we know that we already passed the request and response objects from one servlet to another whenever we use the request dispatcher objects. So we can set this shopping cart object on this request attribute or on this request object, and since this request object is being passed to the second servlet, I can simply call the get attribute method on the request object from my second servlet and get back the same shopping cart object, right? So this essentially helps us in keeping a consistency on the objects that we are working with when it comes to shifting from one servlet to another. All right, as you can, so one last time, the scope of this request attributes is as long as your web application is serving that request. So once your web application sends back the request to the client or sends back the response to the client, then these attributes, that is, this request attributes, are going to be destroyed. All right, now let's talk about page scoped attributes. So page scope attributes are generally valid for JSP pages only. You see, in case of JSP pages, when it comes to using action tags that we have studied in our last lecture, it is possible for us to set multiple properties using JSP action tags, and it is also possible for us to set the scope for those properties inside those action tags as well. Now, as for the scope of those properties, we can set the scope as page. So what happens when you set the scope as page is that those properties or those attributes are going to be available only as long as the request for that page is being processed. So as soon as your web application sends back a response to the client for that particular page's request, then those attributes which have the page scope are going to be destroyed. Okay, so we will be seeing an example related to JavaBeans later on, which will make this concept more clear. All right, now we move our discussion to JavaBeans. A JavaBean is simply a standard. It is simply a fancy name for a simple Java class that provides a no-argument constructor, and it implements the java.io.serializable interface. It may also have getter and setter methods for its private attributes or for its private properties. Now, if you're wondering what the purpose of this interface is, well, just remember for now that serialization is the process of persisting an object from memory to a sequence of bits so that you can save that object onto your disk. On the other hand, deserialization is just the opposite process. It helps in reading data from your disk and converting that data into an object. So essentially, when you implement this serializable interface, you essentially define that your JavaBean object can be converted into a sequence of bits for saving it onto your disk, And if you ever want to reconstruct that JavaBean object from your disk, you can also do that as well. Also, JavaBeans are used for two things: executing business logic between multiple layers and for carrying data between these layers. So we already know that in case of an MVC architecture, uh, the controller simply passes information from the view to the model, and this model employs different kinds of JavaBeans to perform business logic on that client's request, and then sends back the response to the controller, and the controller then sends back some kind of response to the client, right? So that's what JavaBeans are for. So the way we can define this JavaBeans is actually pretty simple. So suppose I am trying to create a class called counterBean, and since I want to define this class as a JavaBean, I am implementing the serializable class. Now inside the serializable class, you can see that I have a private variable called counter. Now, if you remember, the first condition for being a JavaBean is that it must have a public no argument constructor. So I have a no argument public constructor here, and all it does is simply initialize my counter variable to 0. And after that, I have the getter and setter methods for my private variable counter. So this counterBean class satisfies all the conditions of being a JavaBean, and so we can say that this class is a JavaBean class. So that is all you need to know for now when it comes to JavaBeans. It is simply a class that implements the serializable interface, and it has a no argument public constructor. Okay. So now let's take a look at the JSP Standard Action tags involving JavaBeans. So before moving on to discussing the use of action tags involving JavaBeans, let's try and understand a few things first. And we know that JSP gives us the opportunity to include any kind of Java code inside our JSP page by using scriptlets, right? However, it is actually discouraged to use too many scriptlet codes inside JSP pages. You see, since JSP follows the HTML syntax, we can say that JSP is a markup language, right? So since it is a markup language, it contains all the tags that we use inside HTML, like HTML body, H1 tags, H2 tags, and so on. That is, it follows a markup language syntax. Now, if we have too many scriptlet codes inside JSP pages, then it creates a kind of inconsistency when it comes to the code that we have written inside our JSP page. So since this kind of inconsistency usually causes different kinds of issues down the line, for example, it may cause manageability issues when it comes to large projects. At the same time, it kind of creates confusion when it comes to understanding the different kinds of operations that you're trying to perform by using your JSP pages. So usually, it is encouraged to use JSP style tags whenever you want to perform any kind of activity inside your JSP page. And that is the main purpose of behind why this JSP standard action tags were developed. So let's see how this JSP standard action tags perform when it comes to JavaBeans. So let's take our previous example again, our previous counterbean class, which is a JavaBeans since it follows those standards set out by JavaBeans. So suppose we want to create a JavaBean object inside our JSP page, right? Now, if we want to create a JavaBean object of this counterbean class inside our JSP page, then obviously we could have used scriptlets. So we could have done something like this. We could have created a scriptlet, and inside of that scriptlet, we could have created a counterbean object. We could have used the setter and getter methods like this as well. But since this is discouraged, so we will be using JSP standard action tags instead to perform this same things, to perform these similar things. All right. So let's see how action tags work first. Now, to create a JavaBean object inside a JSP page by using standard action tags, we use the JSP useBean action tag. Now, this useBean standard action tag has a couple of attributes like ID, class, scope, and some others as well. But these three are the most important when it comes to creating an object or creating a JavaBean object inside your JSP page by using the useBean action tag. So let's see what this attribute does. The ID attribute is used to define the unique name for your JavaBean object. So for example, if you want to create an object for your CounterBean class, you will have to name it something, right? You will have to name that CounterBean object something. So in this case, we are using this CounterBean as the name of our object. So if we were to use JSP useBean action tag to create this CounterBean object, then we would have written ID is equal to CounterBean here, right? Next, we have the class attribute. This class attribute is the name of the JavaBean class whose object we are creating. So fully qualified class name means that we have to write down the name of the class, including the package to which it belongs. So suppose this CounterBean class belongs to our com.beans package. Then in this case, we would have had to write com.beans.counterbean. Okay. Next, we have the scope attribute. Now, the scope attribute defines the scope for which this object that we are creating will be valid. Now, if you remember, the valid values for this scope attribute are page or request or session or application. So we have 4 scopes we can assign our object to. Now, if you remember, this page scope is only valid for JSP pages, as we discussed in our last slide. So if we want, we can assign our object to any of these 4 scopes. Okay. Okay. Now comes the use of getter and setter methods. Now, obviously, we are trying to avoid writing scriptlets, and so we need some kind of action tag for replacing the use of setter and getter methods as well. So, or replace the use of calling those getter and setter methods as well. So the way we can do that for setter method is by using the JSP set property action tag. So in this case, we will be using the set property action tag to replace calling that setter method of our JavaBean object. So as you can see, this set property action tag has 3 attributes: name, property, and value. So let's see what this properties do. The name attribute refers to the JavaBean object whose property we are trying to set. Okay, so if we are working with the CounterBean object that we had created here, then in this case we would have written CounterBean. Okay. Next, we have the property attribute, and the property attribute defines the name of the property whose value we are trying to set. So suppose in this case, we are trying to set the value of the counter property. That is, we are trying to set the value for this counter private variable. Okay, so what we would have written here is property is equal to counter. And if we want to initialize the value of this counter variable as 5, then we would have written value is equal to 5. Okay, so that's how the set property action tag works. Finally, we have the get property method, or the get property action tag, which is used to replace calling the getter method. Now, this attribute has action tag has only 2 attributes: name and property. So name is the bean name, that is in this case CounterBean, and property is equal to the name of the property whose value we are trying to get. So in this case, we would have written name is equal to CounterBean and property is equal to counter, right? And that would have returned us the value of the counter variable inside our CounterBean object. So now let's take a look at what this all looks like when we actually write them down inside our JSP page. Okay. So now let's take a look at an example to understand how all this JSP standard action tags involving JavaBeans work. All right, so we have a personBean class here, which is the JavaBean that we will be working with. And as you can see, this personBean is located under the package com.beans in our case. All right. Next, we have, as you can see, 2 private variables, string firstname and int NID. And we have our no argument public constructor here, as well as the getter and setter methods for these 2 private variables. Next, we have our index.jsp page here, where we will be using our JSP standard action tags for working with this personBean object. Now, since we will be working with this person bin object, as you can see, the first line here inside our JSP page is the page import line. That is, we're importing the package pom.bins.personBin, since we will be working with this person bin class. Next, next we have some pretty straightforward things. We have our HTML tag, our head tag, and then we start our body tag, where we will be writing our main stuff. So at first, for demonstration purposes, we have created an object of the java.util.date class, and we have used id is equal to date. So that means we are creating an object of the java.util.date class with the name date. Okay, so we will have a date object. And we have set the scope for this object as page, and the type of this object as java.util.date again. Then we are using an h1 tag to print the current date by utilizing that date object that we just created. And to get the value of this date object, we are simply using a JSP expression tag. All right, so this line here is going to print the current date for today. After that, we will be now what we want to do after this is we want to create a person bin object. Okay, and for that, what we are doing is we are using our JSP useBin action tag. And inside of this useBin action tag, we are using id is equal to person and class is equal to com.bins.person name. So essentially what we are defining is that we are creating an object of this person bin class, and the name of that object is person. All right, and we have set the scope for this object as page. Next, we are using the JSP set property action tag to set the property of the NID attribute of this person object, or of this person bin object. So inside this set property action tag, you can see we have defined the name is equal to person. So it defines that we are using this set property method on this person object that we have created, and the property which we are trying to set is the NID property. All right, and the value of this NID property is going to be 256. Similarly, we have called the set property action tag again to set the property of the first name attribute that we have inside our person bin object, and we have assigned it the value on us. Okay, and finally, we are using this h3 header tag to print the value of the first name and NID of this particular user. So in this case, what we did is we are simply using the JSP get property action tag. And inside of this get property action tag, we have defined name is equal to person, which basically signifies that the object whose value we want to get is the person object that we had created here, and the property which we are trying to get is the first name property. All right. Similarly, we have another get property action tag here, and in this case, we are writing down the name of the property as NID. So this will return us the name of the value of the NID that we have set here for our person object. So let's see what the output looks like when we actually render this in our web page. So as you can see, we are getting the first line of message as the current date for today, since that was our first line. So essentially, we are utilizing that date object that we had created to print out the current date for today. And then what we did is we have another line of message that prints out the first name and NID of our user, which we had set as Anas and 256 respectively. So we can see that our JSP standard action tags are working, and we really did not have to use scriptlets to get our job done, right? So now we move our discussion to common design patterns. So what exactly do we understand by design patterns? You see, design patterns are actually software solutions that can be used as templates to solve commonly occurring problems in software design. These design patterns are not meant to be finished products that can be directly converted to a programming language. Instead, they speed up the development process by providing tested and proven development paradigms. Now, you might ask, why do we need to use design patterns? Well, you see, even though it is possible to have multiple solutions for a particular problem, only a few of them can be regarded as good. A software solution that follows a good design pattern helps in removing redundant code. It provides proper separation of concerns, and at the same time, it allows reusability of code and much more. So for our discussion today, we will be limiting ourselves to the discussion of two design patterns. These are Model 1 architecture and Model 2 architecture. So let's go ahead and take a look at each of them. Model 1 architecture is known for its simplicity. It is known as a page-centric architecture because the way it performs is mainly dependent on the number of pages that you have inside your web application. So suppose your web application has 3 web pages, and if your client has any request for any of those particular pages, then that request is processed by the page itself. And so the name page-centric architecture comes from there. So each page may employ a JavaBean that processes the business logic operations, or maybe the page will be responsible to handle that business logic operation itself. Essentially, each page will be processing its own input. Now, if we look at this diagram here, we can clearly understand how a Model 1 web application works. So this web application follows the Model 1 architecture, and it has two views, view endpoint 1 and view endpoint 2. Now, these views can be generated by either JSP or by servlets. It does not really matter. What's important here is any request that is coming for this first view, that is view endpoint 1, is going to be handled by the view itself, and the processing is going to be done within the view. And finally, the response is going to be sent from the view to the client. Similarly, if there is any request for the second view, then that request is going to be processed inside this view, and then the response is going to be sent back to the client from the second view. Now, even though this Model 1 architecture may look really simple and attractive, it obviously has a lot of glaring problems. So as you might have guessed, the first major problem of Model 1 architecture is the fact that there is no clear separation of concerns here. So as you can see, we have the presentation logic as well as the business logic on the same layer here. And so we do not have any clear separation of concerns in this case. So no clear separation of concerns leads to another problem, which is difficult to collaborate. So suppose you have hired a developer to work on the presentation logic, and you have hired another developer to work on the business logic. But since both of this presentation and business logic are on the same layer, one of the developers will have to sit while the other developer works on that layer, and then the second developer can take over, right? So they cannot really collaborate on the same project. Also, this kind of architecture is absolutely a no-go when it comes to large projects, because you can already imagine if there is no proper collaboration between developers, then you can't really work on large projects, right? So Model 1 architecture also has different kinds of issues like code reusability issues. So code reusability becomes an issue as the view logic and the business logic are too deeply intertwined with one another. So this kind of design limits the development of dynamic web applications to developers who have the knowledge of JSP and servlet. This kind of architecture cannot be expanded to web applications that use some other technologies. Okay. So now let's take a look at an example to understand how exactly this Model 1 architecture works. So suppose we're trying to develop a news application which will be employing this Model 1 architecture. So our web application is going to be a simple news site that allows the users to view the current news, to view the about information of this web application, which may contain copyright information as well as information about your news source. And finally, it will contain a add news section where the users will be able to add news on their own. So it will have an index page, which will simply contain some 3 hyperlinks, which will be redirecting them to the about section, to the view news section, and the add news section. And it will have an about page, a view news page, as well as an add news page. So essentially, this web application consists of these 4 pages. Okay. And also this about, view news, and add news page will be connected to some kind of database, which can be a file system or it can be a simple XML file as well. Now, the important thing to note here is whenever a client requests for any of this page, so a client can request for any of the pages here. And whenever a client requests for any of this page, suppose the client has at first requested for the index page. Now, the index page is simply a static page which contains 3 hyperlinks to this 3 about, view news, and add news pages here, right? So it does not really contain any dynamic code, or it does not really need to have any business logic inside this page. This about page here is also going to be a static page, or it might be a dynamic page depending on what requirements you have set up. So suppose this about page is to show the information about your website as well as the copyright information. So you can hard code those information inside this about.jsp page, or you can write some business logic inside this about.jsp page, which will extract that copyright information from your database and then display it to the client. Next, we have this view news page, and this view news page, whenever a client will request for this view news page will contain some business logic, which will essentially extract the current news from your database and then display it to your client. Okay, and finally, we have this add news page, which also contains some business logic, which will take this form action, or which will contain the information that the client has filled up inside this form, and then it will write some code, or it will contain some code to write that information inside your database. So as you can understand, all these pages are self-sufficient. That is, they are responsible for handling the request, for processing the request, and sending the response to the client, right? So we can understand the simplicity of Model 1 architecture from this example, right? But as we have already stated, if this was a larger web application, then we would have had a lot of problems maintaining this project, right? So we would not be able to collaborate among business logic developers or presentation logic developers simply because all of those code is intertwined with one another. And so, since there is no clear separation of concerns here, it will be difficult to apply a proper division of labor in this case. Okay, and so all the problems that we have discussed when it comes to Model 1 architecture are present in this example, right? So now let's take a look at Model 2 architecture, which aims to solve these problems. The Model 2 architecture is essentially the MVC architecture, that is the Model View and Controller architecture. So since it follows the MVC paradigm, it defines a clear separation of concern for the presentation logic as well as the business logic. Now, presentation logic consists of everything needed to format the information into a form that the client can see and understand clearly. By separating the presentation logic from the business logic, both parts are kept simple and are more easily manipulated and can be managed. So to recap what the model view and controller is in the MVC architecture, the model component is a representation of the application's repository and the code involved with reading, writing, and validating information. Basically, what this means is the model is responsible for handling the business logic of your application. The view component is responsible for interacting with a user. That is, view component is what the user will see whenever he or she will interact with your application. The controller component links the two components and is responsible for providing a proper view to a user and keeping the model updated. So a Model 2 architecture, in case of using JSP and servlet technologies, is indicated by the presence of a controller servlet between the client browser and the JSP pages or the servlets which represent the view content. The controller servlet examines each of the requests that are coming to your web application, and upon deciding what kind of request it is, it will be redirecting that request to the appropriate view or to the appropriate model which will be generating the appropriate view for your client. So if we take a look at this diagram of a Model 2 architecture, we can understand how web applications that employ the Model 2 architecture works. So as you can see, we have three layers: a controller layer, a model layer, and a view layer. So whenever a client sends any request for your web application, it does not matter what kind of request, that request is going to be at first received by your controller. Now this controller may be a filter or servlet or anything else, right? Now this controller is going to determine what kind of request your client is making. That is, the controller will determine for what resource this request is intended for. Depending on the request, the controller is going to redirect that request to the appropriate model. So it can be for model 1 or it can be for model 2. Now these models might employ various JavaBeans, that is a collection of JavaBeans or a single JavaBean, to actually process that request. These models might also communicate with your backend database to perform some database related operations as well. Now, after your model has performed the proper processing on that request, they will be generating the appropriate views for the client, right? Now, after these views have been generated, they will be handled by the controller, and they will be sent back to the client as a response. So this is how the Model 2 architecture will work in case of any web application. Now, if we imagine the same news site web application that we had developed using the Model 1 architecture, let's try building it by using Model 2 architecture this time. So if we follow the Model 2 architecture paradigm, we will get something like this. As you can see, any request that is coming for this web application is at first received by this controller. This controller is going to determine what kind of request that the client has requested. So depending on the kind of request, this controller is going to redirect that request to the appropriate model here. So in our model layer, we might have a number of models. So these models are essentially going to be JavaBeans, which are going to contain the business logic for handling that request. Now this model layer may be connected to a backend database from which these models will be extracting any kind of information that is in our database. Okay. Now, depending on how we write our business logic, we might have a couple of models here, that is a couple of JavaBeans here. And these JavaBeans are going to contain the business logic for handling that request, as we have stated. And after the processing has been done for that client's request, the models are going to generate the appropriate view for the client by calling this index, about, view news, or add news page. After the models have generated these pages appropriately, these pages are going to be sent back to the client as a response by the controller here again. Okay, so that is what is happening inside this Model 2 architecture, or inside this web application that is using the Model 2 architecture. So right off the bat, we can see a lot of improvement by using the Model 2 architecture in our web application here. Now, if we want, we can hire a separate group of developers for our presentation logic and a separate group of developers for our business logic. So we do not have to worry about separation of concerns anymore, because since all the presentation logic and business logic are properly separated by using these two layers here, so we do not have to worry about we do not have to worry about the Since the view layer and the model layer are separated clearly here, we do not have to worry about this two presentation and business logic layer intertwining with one another anymore, right? And so this solves almost all the problems that were mentioned in the Model 1 architecture. So that is it for today's lecture. If you have any question, let me know in our live class. So I will see you then. Take care and stay safe.